Hi, this is Mr. Beck. This is a quick tutorial on scientific notation, a quick review. And so let's take a look at scientific notation. It's really all about powers of 10. And so let's start with this, one of the simplest powers of 10. Let's just do 10 times 10. We know that 10 times 10 is the same thing as 10 squared, right? And 10 squared is going to give me a number of 100. So 10 times 10, 10 squared is 100. Well, what about 10 cubed? Well, 10 cubed is going to be 10 times 10 times 10. And that is going to give me a value of 1,000. Well, I could keep on going up or I can go down. Let's see. Going down, I have 10 to the 1. Well, if that's 1,000 and that's 100, well, 10 to the 1 is just really 10, right? So 10 to the first is just a value of 10. Now, looking at the patterns here, I can go up to higher values, and we typically go in like from 3 to 6 to 9. 10 to the sixth is going to be 1 with 6 zeros. And so this is actually going to be a million. This one is 1,000. This one is 100. And of course, the next one is just 10. And I'm not going to write all of those, but you know what it would be. Just, 10 times 10 times 10, 6 times, right? So we've got million, thousand, hundred, 10. Well, that's 3, 2, 1. What would 10 to the 0 be? Well, this is a 1 with 3 zeros. That's 10 to the 3. This is a 1 with 2 zeros. That's 10 to the 2. This is a 1 with 1 zero. That's 10 to the 1. Well, I guess 10 to the 0 is 1. So that's interesting, that 10 to the 0 is 1. If you ever wondered why, it's because the pattern fits. That's, sometimes math patterns are useful. Now, I don't know what to write over here. It's really 10 times, well, not times anything. So anyway, let me just leave that blank. The next one, if I'm going 3, 2, 1, 0, would be 10 to the minus 1. Huh. Well, 10 to the minus 1 is really the same thing as 0.1. And that is going to be what we call a tenth. And so 10 to the minus 1, that's the same thing really as 1 over 10. So that 10 to the minus 1 is 1 over 10. So continuing down this pattern, I have 10 to the minus 2. Well, that's going to be 0.01, and that's going to be 100th. And then, so that's going to be 1 over 10 times 10. Then the next one down, I would go 10 to the minus 3, and that's going to be 0.001, and that is actually a thousandth. And so that is really 1 over 10 times 10 times 10. That's 10 to the minus 3. And I could keep on going. Let me just throw 1 in here, 10 to the minus 6th. And that, I'm not going to write it all out. And that's going to be a millionth. And so that's 0.000001 is a millionth. So that's like 6 places. So this is the basis of powers of 10. And so that's where the 10 to the 0 equals 1 comes from, if you ever wondered. But this is the base of scientific notation because we're always going to write some number between 1 and 9.99999 times 10 to the something or other. And so every number is going to be some factor of that. So keeping that I just worked out in slightly different format, but here's my powers of 10. So in scientific notation, what I want to have a number where I'm always going to have a number between 1 and 9.999. I only want one digit to the left of the decimal place. So if I had 376.4, I only want one number to the left of the decimal. So I'm always going to pick that first significant digit there on the left. So I would start with 3.76. So I always want just one number to the left of the decimal. If I had 376.4, then that's not proper scientific notation. I need 3.764 to get there. Now the other thing is, how far did I move the decimal point? Well, 376.4 is really 3.764 times 100, right? Because it's 376. So another way to get that is 303.764. That's times 10 to the 2. It's times 10 squared, and that's the proper scientific notation. And so that 2 tells you how many times you move the decimal place. There's 2 moves of the decimal to get to 3.764. So any number you have to move the decimal around until you get just one significant digit there to the left of the decimal. And then you have your 10 times 10 to the how many times you move the decimal. So if I had a number like 0.00415, well, I need one digit to the left of the decimal, so that's going to be 4.15. And now how many times did I move that decimal? Let's see, 1, 2, 3. So that's going to be times 10 to the, is it 3? Well, no, 10 to the 3 is going to be a really big number. This is a really small number. And so if I move that decimal that way, I move it to the right, that's a -3. So that is how you convert from a regular number to a scientific notation, is you're always going to want to move the decimal place to where you've got just one significant digit to the left. So it's always going to be a number between between 1 and a 9 up here, the digit 1 through 9. And then your additional decimals times 10 to the how many times did you move the decimal place. So that's just a basic kind of, interesting where 10 to the 0 comes from and just how to put things in scientific notation. So hopefully that is familiar to you and won't be a problem. Now, one thing that people have trouble with is entering scientific notation on the calculator. Sometimes people want to they want to try to enter their calculator with a times and then typing in 10 and then putting the raised to some power. And so if you're typing that in with the times and a raised to, you are going to run into lots of trouble in working out your math in physics. So you really want to get used to your calculator going the right way. And so the key on a standard calculator, these are just two calculators that I have used all the time. The key is looking for either the EXP button, which shows up here, or on this TI calculator, you've got this, you've got an EE, and you see right there it says EE. Okay, so you're looking for your EE or your EXP button. There are other calculators that actually have, it'll say 10 to the X. I don't have a picture of one of those, but you've got those three buttons. What does that button mean? That button means, and I like to draw this word, it is this word. That button means that is your times 10 to the button. Okay, times 10 to the. Think of that as a single word, single button, one word. Now, on this calculator, you just press the button straight away. There's your times 10 to the. In order to get to that EE, you actually have to do second and then EE. And so if you wanted to enter 3.4 times 10 to the 6th, I would enter, so if you really wanted to get to, say, 3.4 times 10 to the 6th, you're going to do 3.4 times 10 to the 6th. So you would enter 3 as that number. You'd have the decimal point number. You'd have the 4 number. And then you'd have your, in this case, EXP button. And then you would have your 6. If you enter it in that way, it's going to hold it together as a single number, and it won't try to split it out into the two different things you're multiplying. On your other calculator, it would be 3.4 second. And then what is that button? It's actually the little comma button with the EE above it. And then you'd have your 6. So you have to know how to use your calculator in order to get scientific notation in there. So if you were doing the practice problems and you were winding up with factors of 10 with the scientific notation exponent being completely off, this is probably the problem. So do not use your caret button. You don't want to use that. You don't want to use your times button. Okay, so none of that when doing scientific notation when entering the scientific notation value. Sure, you'd multiply one scientific notation by the other, but this will keep it together. So that is your hint for scientific notation on your calculator.